entrance and beyond. Today I will be discussing question number 20. This is day 13 of my DSA series. So today I will be discussing question number 20, that is valid parentheses. So let's dive right in. So the question states, given a string S containing just the characters open bracket, close, open parentheses, close parentheses, open curly bracket, closing curly bracket, bracket, and closing bracket, determine if the input string is valid. An input string is valid if 1. Open brackets must be closed by the same type of brackets. 2. Open brackets must be closed in the correct order. And 3. Every closed bracket has a corresponding opening bracket of the same type. So for example, S is equal to this. So we can say that we basically open brackets must be closed by the same type of bracket. So this is the opening bracket, it is closed by the same kind of bracket. Second condition, open brackets must be closed in correct order. So that means after the opening bracket we must have closing bracket. That is also correct. And third, every closed bracket has a corresponding open bracket of the same type. So you can say that this is a closed bracket, it has a corresponding open bracket of the same type. We can return to. Over here, if we see now, this bracket would cancel this would cancel this would cancel this would cancel this. So this works. Over here, why doesn't work? We can say that open brackets, this open bracket is never closed by the same type of bracket, so this is not obeyed. We can return false. Over here, this is always going to be true because this gets removed by this gets removed by this, and then in this case again we get false. So that is all that we have to do. We basically have to return true or false, and we have to give true if it is a valid parentheses sequence and false otherwise. So I'll basically copy this test case and just so that you get a bit more idea about what exactly we are supposed to do. So this is what we have, right? This is a test case. So what can we see? If I just use a simple pointer approach, you can see that suppose we start off at this. So what's the condition? The condition says open bracket must be closed by same type of bracket. So you can say this open bracket is closed by the same type of bracket. Secondly, open bracket must be closed in correct order. So it is closed in correct order. By correct order we mean for this bracket, the correct order would be directly encounter a closing bracket, so as to say. And then every closed bracket has a corresponding open bracket. So this would basically work. Like what happened is that this sequence would become valid. Then we look at this, these two get cancelled, these two get cancelled as well. So we can say that it is valid parentheses. And if that is not making sense, I'll basically show a stack and maybe explain how to do it. So you probably understood that this is a stack question. If you haven't done stack questions again, this is a basic stack question. And we basically have to cancel out brackets. If I explain it in simpler terms, we have to take brackets, we have to cancel them out. So what we can say, when the stack is empty, we basically run a loop that runs through this entire sequence, right? So let's say I is over here. When the stack is empty, we can push this in. Then what do? I comes over here, right? Now what do we see? We compare the top and current. So we can say the top and current are opposite brackets. So they're brackets of the same time. One is opening, one is closing. That means a match has been found. So we can pop this out. Then I moves ahead again. Stack is empty. We can push this bracket in. I moves ahead. And what did we say? We compare the current element with the top. And as we can see, they are basically opposites. Since they are opposites, what can we do again? We can basically pop this off. So this means the matching pair for this element's matching pair is this element. Then we can have a curly bracket, do the same thing. I is over here, curly bracket. Now I moves ahead. Now we compare both of these, and when we compare both of these, they are opposite, so we can cancel this. And since our stack is empty, we can basically conclude that this was valid. So essentially we just have to cancel out parentheses against each other. That is what we essentially have to do. The question might seem complicated, but that is all we have to do. We have to basically cancel out parentheses against each other. So let's look at this case. So let's look at this case. So this is another test case that we had. So let's see what happens in this case. I'm going to show the simulation and hopefully things will make sense to you. So let's see, we start off over here. I'll use a different color. Let's remove this color. I'll use something that looks a bit more clear. Yeah, so we start off over here. We start off over here at this element. Since our stack is empty, we can put it. Now we come to this element. Now we see a match. These are not opposite signs, right? They're not of the same type, so we can push this in as well. Then we encounter this element, this and this. So we basically compare the top and current element. There are opposite signs. We can pop this out. We have one element again, so stack.top and this is of the opposite sign. We can pop and we can return true. That is all that you have to do. So I'll take a test case where things turn out to be false. that would help you understand when we can say a sequence of parentheses is actually invalid. So let's look into that as well. So simple, this is what we have. We basically start off over here with our first element. Start off with the first element. Since the stack is empty, you can push it. You can be compared stock dot top and this element, they're not of the same type anyways and they're not opposite, so we can push this in. Now encounter this, we compare with the top, they're not opposite, they're not of the same type, we can push it. Now encounter this, these are not of opposite types, you push it, and since our stack has elements, we can say it's invalid because the parentheses aren't getting cancelled out. So that is the main crux of this question. So I'll write the code, so you can try it yourself if you're confident enough. So for stack, this is how we declare stack in C++. We take a stack and we're going to push character, right? So stack, then data type, it's going to store st, and then we're going to run a for loop. So we can run an auto for loop. So character C of s, this is basically auto range based loop. We can check that syntax out. This is basically saying that we are basically taking a character C which is traversing through our string. So what do you check? First of all, you can check if stack is empty. So when the stack is empty, you don't really have to complicate it. We can do stack dot push. What do we push? And push the character. So this is just basically a for loop where we're take character C which is iterating through it. For example, in this case, character C would be this and character C would be this, so on and so forth. So if the stack is empty, we can simply push. Else if stack dot else if C is equal to opening, or C is equal to closing, and we can say this stack dot top is equal to opening with the character we can use single, and our character is equal to closing. Or what's the second case? The second case, let's just copy this, so it would be slightly easier. So what would our second case be? Our second case would be for the second set of second type of bracket, you can say. So the second type of bracket was basically our curly bracket. This again is going to be curly bracket. It's going to be closing curly brackets, keep mind of that. And then we'll have our final or. Stack dot top is equal to opening bracket, closing bracket. We'll add another parenthesis for this, for the outer parenthesis. Now if this is the case, we can just do stack dot pop, and if this is not the case, again we can push. We can basically push in the else condition. We can just do stack dot push C. So this is our for loop. Then we can say if in the end stack is not empty, the stack is not empty, we can return false. Else true. This is the code pretty much. So we start off with the stack, we traverse through our string. If the stack is empty, do stack dot push. So this has to be done in the start, because you're probably wondering why can't we just combine both of these, this if and in this else. We can't, because we first have to check whether the stack is not empty, so we don't want to do that repeatedly. So we just, if the stack is empty, directly push. Else if the stack dot top and current element, they are of opposite signs. So basically there's three type of brackets, so we mentioned all of them. If they are of opposite signs, you can pop. Else in the other case, when basically a stack has elements, they're not of opposite signs, you can simply push it in. And then in the else, we check if stack is not empty, we can return false, else we can simply return true. And that is pretty much all that we have to do in this question, particularly for the C++ approach. As you can see, all the test cases have run perfectly. So hopefully this video helped you out, and stay tuned for more videos. So yep, that was the best approach to this question. So thank you so much for staying till the end.